For the following matrix equation, solve for A, B, and K. So here we have this matrix equation, and our goal is to solve for A, K, and B. Okay, so first of all, notice that we have this matrix equation. What we're going to do is we're going to multiply. So we have negative K multiplied by 1. That gives us negative K. Negative K multiplied by 3. That gives us negative 3K. Negative K multiplied by negative 2 gives us positive 2K. And negative K multiplied by 0 gives us, negative K multiplied by 0 gives us 0. And so we have this matrix, and we just bring this one down unchanged, and we also bring this matrix down unchanged. Now we have to add the matrices that are on the left-hand side. And so we say 7 plus negative K. That's what we have here, 7 plus negative K. Then we say 0 plus negative 3K. That gives us 0 plus negative 3K. Then we have 1 plus 2K. So we have that here, 1 plus 2K. Then we say A plus 0, A plus 0. So we have to add corresponding entries. Whenever we add them, we add corresponding entries. So let's simplify this matrix. We have positive times a negative is a negative. So this is 7 minus K. And positive times a negative is a negative. So if we have 0 plus minus 3K, that's definitely minus 3K. 1 plus 2K, we cannot simplify that because they are unlike terms. And A plus 0 is simply A. And so we have this matrix is equal to this matrix. Now, if these two matrices are equal, then that means that corresponding entries must be equal. And so that means that 7 minus K must be equal to B. That means that 3 minus K, negative 3K must be equal to negative 12. That means that 1 plus 2K must be equal to 9. And that means that A must be equal to 5. Because if these two matrices are equal, then corresponding entries must be equal. So let's use this equation to solve for B. We're going to, no, we're not going to start with B first. We're going to start with this one. So we're going to use this equation here to solve for K. What we're going to do is we're going to divide both sides of this equation by negative 3. We cancel this negative 3 with this negative 3. So we are left with K is equal to negative 12 divided by negative 3. And negative 12 divided by negative 3 is equal to positive 4. Next, we're going to solve this equation for K. We take the 1 and we send it over the equal sign. It was a positive 1. When we send it over the equal sign, it becomes a negative 1. And so what we have is 2K is equal to 9 minus 1. And 9 minus 1 is 8. So we have 2K is equal to 8. We divide both sides of this equation by 2. This cancels with this. So we have that K is equal to 8 divided by 2. What is 8 divided by 2? 8 divided by 2 is definitely 4. So K is equal to 4. So in both cases, we have that K is equal to 4. So that's good. We know that A is equal to 9. But what is B, right? So we have to solve for B. So we are going to, okay, I understand. So we know that this is 7 minus K is equal to B. But what is K? Well, K is equal to 4, right? So K is equal to 4. And so that means that we're gonna substitute 4 for K. So we're gonna replace K with 4. So we have a 7 minus 4. Instead of K, we put 4. And 7 minus 4 is equal to B. What is 7 minus 4? Well, 7 minus 4 is definitely 3. So that means that B is equal to 3. So we have B is equal to 3, K is equal to 4, K is equal to 4, and A is equal to 9. And that's the answer to this question.